Hello everyone, welcome to part 3 of this BVW Photon tutorial video series. If you haven't checked out part 1 and part 2, I definitely encourage you to go and check that out before you get into part 3. Um, so like I've said before, what I'm going to do in part 3 is more of explain what are the things you need in order to implement gameplay using Photon. I've tried to make this as short as possible and I've included a lot of different things that you need to know. What I'm not going to do is show you how to implement gameplay code. That is something that you already know because now you have done a lot of BVW. I'm sure you know how to implement gameplay things in Unity. What I am going to do instead is show you how you can implement the networking part using Photon and what are the things that you need to know in order to get started. This video does not cover everything there is to know about Photon, so I definitely encourage you to go check out the documentation yourself, check out some of these demos yourself, and also check out some YouTube tutorials, one of which I have found to be really good, and I'm going to put the link to that in the description of this video. So with that being said, let's get started with part 3, which is going to focus on the gameplay. Okay, so when it comes to implementing gameplay, Photon makes it very easy to create a networked game. Um, and there are like a few conventions that you need to follow that are mentioned on the Photon website. And as long as you're doing that correctly, you won't have a big problem implementing gameplay. So the first thing is instantiation. What this refers to is that how do you instantiate networked objects so that if you instantiate it on one client, everybody has that instantiation on their client. Um, the most important rule here is that network prefabs, so prefabs that you want to instantiate over the network, must be stored in the resources folder. So for example, if we look at the demo asteroids game, they have a resources folder where they store the spaceship, the small asteroid, and the big asteroid. And these are the objects that they will instantiate during runtime when the game is playing and there are multiple people in the same room or like in the same game. The other condition is that all of these networked prefabs must have the photon view component. This is extremely important. So we'll discuss about photon view in more detail, but the basics is that the photon view is like a networked identity for any object that needs to be networked in the game. Photon view component can be added very easily. You just click on add component, and as long as you have photon uh, in your assets folder, you will be able to see photon view and you can add it just like adding any other component. So yeah, make sure you add the photon view component to network game objects. You keep the prefabs in the resources folder and you should be good to go. The method that you will use to instantiate objects over the network is photonnetwork.instantiate. And you then have to pass in some arguments. To give you an example for this, yeah. So this is where they instantiate the spaceship. There is a position and rotation that they pass in. This fourth value can be 0. It's not too important. It's basically the group of the object, and you don't really need to worry about that. Um, so yeah, you call this function like this, which is very similar to gameObject.instantiate, and you should be able to instantiate networked objects. The last thing that you need to worry about is that object instantiation will happen at the same position and rotation as is specified in the photon network.instantiate function. Now, this is obvious, but what is not obvious is that if a player joins later after the object has been instantiated, for the new player, the object will be instantiated at the same position and rotation that was specified earlier, even if that object has been moved. So let's say that my spaceship was instantiated over here, and I have then moved to to let's say this place, and then a new player joins. Now, in the instant that the player joins, uh, my spaceship will be over here. But because my spaceship's transform is being synchronized over the network, it will quickly snap to the new location, which is the current location. But the thing to remember is, and this can cause some bugs, is that during the start or during as soon as the new player joins, the original position that was passed for instantiating that networked object is where the object is going to be instantiated. So you need to be a little bit careful about this. The original position of where you're instantiating a networked object is extremely important. So that's about instantiation. Okay, let's talk about ownership. Um, so here we'll talk more about the photon view component. So there's owner whenever you are making a network game, there's ownership because there are objects that will be in your game that are owned by a particular player. Now the ownership is specified using the photon view component. To give you an example, so I have a spaceship, and I see that in the photon view there is this ownership option. Now, the important thing is that ownership can be transferred. Uh, but if I have it fixed, it cannot be transferred. If I want to transfer ownership during runtime, then I can put takeover as the ownership transfer. Takeover means that you don't really need to request. You can just take over ownership whenever you want. So any player in the game room can take over ownership of the object whenever they desire. So that's takeover. And the third one is request. So request means that you cannot just take over. There needs to be some sort of confirmation, and only then can you take over ownership. So these are the three options. Now, the spaceship is like the main thing that is controlled by players in this environment. And as a result of that, the ownership of the spaceship is fixed because one player does not need to control two spaceships. Um, so that's about ownership. The other thing that's important here is that when you use the photon network.instantiate function, you become the owner of the object that you instantiate. So the client on which the photon network.instantiate function is called. So in the example, you can see that there's a photon network.instantiate. So the client on which the photon network.instantiate function is called, that's the client that will become the owner of that object by default at the start. The ownership can change if the setting is set as takeover or request, but at the start, the ownership will be of the client that calls the photon network.instantiate function. So that's another thing that you need to be careful about. Um, yeah. Okay. Now, under ownership, there's another point. There are like three different forms or like three different entities that can own an object. The first one is player owned. This basically means that that object is owned by a particular player, and this is the function that we talked about. So photon network.instantiate, if you use that function, you do have to pass in arguments. But if you use this function, then the ownership is player owned. So one player owns the object that was instantiated using photon network.instantiate. Again, ownership can be transferred, but the ownership is of a player. Okay. The next thing is room owned. So there will be some objects in your game that don't need to be player owned. So for example, there can be a door and the door can open close, and let's say that you want to instantiate the door at some point in the game. Um, so the door now does not need to belong to any player. And in this case, it has to be room owned. So room owned basically means that it's like it's owned by the environment. No player owns it, it's owned by the environment. And to instantiate room owned objects, you need to call instantiate room object instead of just instantiate, which is what you call if you want to make it player owned. So if you want to make it room owned, there's a different function. To give you an example of this, uh, the asteroids that you see in the game, the asteroids don't need to be player owned. The asteroids are room owned because no player has control over the asteroids. So what we need to do then is make sure that when the asteroids are instantiated, you can see this in the asteroid.cs script. When the asteroids are instantiated, we are using instantiate room object instead of just instantiate. And the parameters that you pass in are the same. There's some instantiation data that you can pass in, but again, that's not really important. You can read up on the on the documentation about what that is and if you really need to change that. Okay, so that's player owned, room owned, and the last one is scene owned. So scene owned objects are part of the Unity scene at compile time. This means that if there are like walls in the game, or in this example, there's like a star field in the background. It's a particle effect. So this does not need to be instantiated during runtime because this is a part of the game right from the start, and that means that we can keep it scene owned. Uh, so yeah, it's not instantiated during runtime. It is part of the Unity scene at compile time. So that's scene owned, room owned, and player owned. Okay, so the third thing that we need to talk about is synchronization. Um, Again, Photon does a very good job at making all of the synchronization very easy. Um, so one of the most common things that you would want to synchronize is transform or the rigid body. The way you do this is in your photon view. So you have the photon view. You add a photon rigid body view. This enables you to synchronize velocity, angular velocity. And I think rigid body also automatically syncs the transform data as well. So transform only syncs the position and rotation, but rigid body will sync the position and rotation as well as the velocity and the angular velocity. Um, so what you do is that let's say that I was creating a new object. Let me just create a new object and show you from scratch how this would be. Uh, Create empty. Mm, Photon sync example. Uh, this can be empty. It's not a problem. So I drag it in here. Okay, so let's say that I want to sync this object's transform. So what I'll do is I'll first add the photon view because photon view is required for any sort of networking. Okay, so I've added photon view, and then I go and I can add photon transform view. Photon transform view will sync the position rotation. It also adds the scale. Okay, and you see that over here, it has automatically added my photon transform view as an observed component. So whenever the photon view observes a component, it will sync that component over all clients. So the reason it automatically added over here is because this observable search is set to auto find all. I can put this to manual, and I can remove this if I want. Done. Okay, so now there's no component, and then I can drag this in. So it's just the same way of doing this. I can also add a photon rigid body view. When I add the photon rigid body view, you can see that the rigid body automatically gets added. So the condition for having a photon rigid body view is that you already have a rigid body. So I can drag that in, and I can just make sure that the rigid body view is observed, and then I can delete the transform. Okay, so this is basically how you can set up syncing of objects, uh, syncing of data that you require. So you can make it a transform, or you can make it a rigid body um, using Photon. While we are over here, let's talk about these other things. So ownership transfer in Photon view. Basically, we have talked about that. So you have takeover and request. This is for transferring ownership. In observables, you have synchronization. Okay, so this basically determines how the synchronization happens. So there are like three options that you have. If you put this to off, then there'll be no synchronization. Reliable data compress. So this is sort of like how TCP works. So there's like a uh, handshake, and it makes sure that all of the data that is sent from one client is received at the other client. So if, for example, a packet is dropped, then it will resend that packet. And like if you know a little bit about UDP and TCP, you'll know that this process is a little heavy, and it can cause some lags in your game because yeah, it's going to make sure that every packet is delivered. Unreliable basically means that you can uh, like every packet does not need to reach, but it will keep sending packets, and in general unreliable works fine. There's like because you can, if there's lag, you can just snap the position of an object. This is not that big of a problem, especially for gaming. There are some applications where you definitely don't want unreliable, but for live gaming or for real time gaming, unreliable is absolutely fine. And then the third one is unreliable on change. Again, I'm not 100% sure what this means, but I think what it means is that it will it will try to be the first one when it can. It will try to be as reliable as possible, but if it's not possible, then it will be unreliable, and that it's fine with that. Um, so yeah, unreliable on change is sort of the best option that you can go with, and it comes by default. Uh, so that's fine. Okay, and the last thing that we need to look at is remote procedure calls. So remote procedure calls basically is how you can call functions on another client by calling them on your client. Um, so these are networked functions basically. Um, you can, so this is basically so that you can call methods on other players in the scene. Um, the way you do this is that you have this pun RPC before the function is declared, or like before the signature of the function is written. So for example, actually, let me just quickly search. Okay, yeah, found an example of pun RPC. So you can basically use this like that. So you add the tag over here, pun RPC, and then you just write out the function that you need to be networked. And so this is how you declare and write the function. while calling the function, you need to use something like this. So you have photon view. Um, so RPC functions can only be called using photon view object. So the photon view object is going to call this function using a special function called .rpc. Uh, so this function basically takes in the string name of um, of the pun RPC function. So this has to be exactly the same. Actually, this is another function. Respawn spaceship. Yep, there it is. So you can copy this and paste it inside over here, because this uh, the function signature has to be exactly the same. You have to pass in the string name of the function. Then you can pass in targets. Um, we'll talk about the target. And then there's like some, let's say that this function actually took in like a integer. So you need to pass in that integer, and you can do that by doing this. So you can add whatever data you need to pass into this function by putting it over here. Now, something that you need to know is that um, adding data or passing data is not the same as passing data on on your local machine or like in a non-network game. And this is because the way this data is passed is that this data has to be serialized and sent across the network. So while integers and strings are fine, more complex data structures like hash tables might not be serializable. Again, I'm not 100% sure about all the different data types that are and are not serializable, but yeah, just you need to be careful about the kind of data that you're passing in over here. Like, I'm pretty sure that if you have self-declared classes, you cannot pass that, because serializing a self-defined class is quite hard. Um, what you can do, however, is you can there is a function that allows you to serialize the data. You can use that to pass in more complex data types, but that is something that you can search on your own. What my point is that you need to be careful about the data that you're passing in RPC functions. Non-serializable data is going to cause a problem. Okay, let's talk about the RPC target. Now this is cool because let's say you only want to call your function on the master client and not on all the other players. You can basically change the RPC target to reflect what you want to do. Um, so these are the different RPC targets that you can have. The first one is all. All basically means that you call it immediately on your local client, and then you call it on all the other clients, including the master client. Master client means that you only call it on the master client. All buffered. Okay, so whenever you see buffered over here, this means that you are calling it in a buffered way. So by buffer, I mean that if you call a function using RPC target dot all buffered, and a new player joins in after that, because this function has been buffered, it will still get called on their client even if they join in later. So that's all buffered. Others buffered means that it will get called on all the other clients but not on your own client, and it will be buffered. All via server, this means that okay, so when you have this via server, this means that if you call this function, it will not get called immediately on the local machine. It will first go to the server will send it back to your machine, and then it will get called on your local machine. So all via server basically means that there's this additional level of communication involved. um, Now the question arises, why would you ever use all via server? You may want to use that in order to so that you don't have this sort of lag between when event occurs on your computer versus when it occurs on someone else's computer. If both of these things are coming from the server, then it is more likely that the event happens at the same time on yours and someone else's computer. If you didn't do the via server, then it will happen, the event will happen immediately on your computer and a little bit later on someone else's computer. So in order to avoid this, you can use the via server. And the last thing is all buffered via server. This basically means that the RPC call is going to be buffered and it is going to be called via the server. So that's all about remote procedure calls. All right, so that was the end of part 3 and the end of this BVW Photon tutorial series in general. I would really encourage you to check out Photon and make a multiplayer game because it's a good thing to learn, as well as the games that you make are going to be really fun. In the previous years, a lot of the games that make it to festival are games that use multiplayer technology, and it was really fun to make this tutorial. I hope you liked it. I hope you learned something from it. If you have more questions, feel free to post on Piazza, or you can even send me a message in Slack. And yeah, take care and good luck for the rest of BVW.